Alright folks, we are about to hit the big time. We are going to use the TVM Solver. So for this lesson I want to make sure that you guys have your calculators in front of you. It should look kind of like this. Or it could look like this. Something like one of those two things. I'm actually going to be using this calculator right here. It's an older version, but it does the exact same thing as the newer versions that you might have, and any differences I will outline in the video. So in the formula, a equals p1 plus I to the power of n, we have successfully learned how to solve for a and how to approximate the doubling time. Now, this was the rule of 72. What we've also done is we've also been able to solve for that p algebraically. However, what we're going to be using is the TVM Solver now. And what's so great about the TVM Solver on our graphing calculators is we can use it to solve for all other variables and how to find time precisely. The rule of 72 gives us a really good rough estimate of the doubling time, but if we want to solve for time precisely, we're going to have to use a more precise instrument. So TVM stands for time value for money. So we're going to use some old methods, and then I'm going to show you how they translate into the new methods on the calculator. So let's just do this first example by hand. You want to invest $500 at 8% compounded semi-annually for 3 years. Use the compound interest formula to calculate the future value by hand. So let's take out that formula we know. A equals P1 plus I to the n. We know that our P is 500, that's the initial. We know that our I is going to be 8%, so 0.08 divided by semi-annually, so we want to divide that by 2. Our n is going to be 3 times the number of compounding periods per year, which is 2, which is 6. So let's plunk in our values here. Let's go 500 times 1 plus 0.08 all over 2 to the power of 6. Okay, 6. We get a final amount here, so a future value of $632.66. So what I want you to do is burn that in your brain, $362.66. Because what we're going to do is we're going to solve this exact same problem with the use of our TVM Solver. So to access the TVM Solver, what you need to do is go to your apps and then finance, and then you're going to find the TVM Solver. Now I'm just going to show that to you on here. We're going to click this button right here. It says apps. However, the one that I'm going to be using in this video is a little bit older, so there's going to be a little bit of a different method to get there. You might have the same calculator as the one in the video. So, and we're just going to clear everything out. So, I am going to go second function, finance. You will probably go apps, finance, TVM, apps, and then finance. But we're going to come to the same window here, and I'm going to click one for the TVM Solver. Enter. You're going to get something that looks like this. We have an N, a percent, or an I percent, and we have a PV, a PMT, an FV, a PY, and a CY, and then this payment end thing. What do all these things mean? Let's talk about it. So here are the variables that we can solve for. N is just like our other n there. It's the number of compounding periods in total. The percent or the I% is the interest rate or annual interest rate. Here's the tricky thing though, guys. We do not write it as a decimal. We're going to write it as an actual percent. The present value is, or the PV is the present value, or principal. The payment, or the PMT, is the number of additional payments. We won't work with these today, but we'll work with these in the next lesson. FV is the future value. PY and CY are connected, though they're a little bit different. PY is the number of payments per year. And CY is compounding periods per year. For all intensive purposes, these two things should be the same. And then PMT here, and it defaults to end. That means that we are getting paid out for our interest at the end of the payments. You can choose beginning or end, but let's just keep it at the end. All right, so let's use the example from above and fill in the variables. So we want to invest $500 at 8% compounded semi-annually for 3 years. We want to be able to find the future value. So in order to indicate that we want to solve for the future value, we just put a little FV right here. So the number of compounding periods here, we would say 3 years times 2 compounding periods per year. Now what's so great about this, you type that in, 3 times 2, and it comes up with 6, which is kind of silly for right now, but when we're talking about a larger number of years and larger amount of compounding periods, it's actually a really nice feature. The I is 8. We're not going to write it as 0.08 here. We're literally going to write it in as an 8. Our present value is 500. I'm going to say that we're going to type it in as negative 500, and we're going to come back to that explanation as to why. Payment, no additional payments are being used at this time, so we just keep it at 0. We skip down to PY, and we look here, semi-annually. So the number of payments per year and compounding periods per year is the same. It's 2 and 2. Payment, we're just going to keep that at end. Alright, so here we go. Let's type this into our calculator. So the number, so we can just look and see. So n is 2 times 6. No, just joking. 2 times 3, enter. I is going to be 8. PV is going to be negative 500. PMT is going to be 0. We're going to skip over the future value here. And our PY is going to be 2. And our CY is also going to be 2. And we have it defaulted at end. Now we're going to tap up to this future value here. And it will be the same on yours as well. We want to go alpha. Okay, it's kind of like just the second function, but it's kind of like a third function. And anything that is the same color as the alpha on here can be shown up when you hit alpha. So I'm going to hit solve. I'm going to hit enter, but what's happening is when you hit alpha, it's going to solve for you. So I'm going to alpha, enter, and we notice here, hey, 632.66. Look at it. Cool. That is the same thing as what we got up here when we did it by hand, $632.66. So this is actually going to be way faster for you, and this TVM Solver is actually a very powerful tool that we can use.